Hey everyone, so we are in the final section. Hooray, this is so exciting. Okay, so this is actually going to be the only video for this one too. It's pretty short. So we've talked about exponential functions. So now all I really want to do here is just kind of walk you through the graphs of exponential functions. So we'll start with this first example. Let's make a table. And so for both of these examples, what you want to do is you just want to make a table from -2 to 2, and we're going to plug these numbers into our function. So this one, f equals 2 to the x. So I'll walk through this with you. So I've got 2 to the -2. So remember what that equals with the negative exponent. This becomes 1 over 2 squared, right? That's what the negative exponent means. And then I just evaluate that, so that'll be 1/4. Okay, so next I've got 2 to the -1st, so this will be really 1 over 2 to the 1st, so this is just really 1/2, nothing else to do there. Okay, anything to the 0 power always equals 1, so we'll just plug that in. 2 to the 1st, well that one's pretty simple, and 2 squared, that one's also not so bad, right? So now what we're going to do is we're going to plot these points, so maybe you want to pause the video and do that, hit play when you're ready. So here are my points as I plug them in. Okay, and so now I just want to show you the actual graph of this exponential function. So the thing you really want to think about here before you draw it is just a little bit more, you want to be intentional with how you draw it. So the question is, should this graph, when I connect all these dots, should this go underneath the x-axis or not? Well, think about what that would mean. If I have a line that goes underneath the x-axis, that would mean I have some negative y values, and there's nothing I can plug into 2 to the x. I can't plug anything in to turn this function negative, because any negative exponent that I have just turns this into a fraction, so this will never actually be negative. So then if I connect all of this, it's going to look like this. And there's my graph. Okay, so I want to do that again with this one. So why don't you guys pause the video and you can evaluate these values and then graph it and hit play when you're ready. Okay, so if I plug in 1/2 to the -2nd, so now I just flip the whole fraction, so this will actually just turn into 2 squared. You might say, well, what about 2 over 1 squared? Well, what is 2 over 1? It's just 2. So this will be 2 squared, so this equals 4. Then I have 1/2 to the -1. This will be just 2 to the 1st, so this equals 2. So anything to the 0 power equals 1. 1/2 to the 1st will just equal 1/2. And then 1/2 squared will equal 1/4. So I'll plug those in. And once again, you might want to plot these, so maybe pause, hit play when you're ready to see the plot. So let's see, 1, 2, 3, 4, 2, 0, 1. Here's all my points. And so similar reasoning as before. So when you connect these, so this y value should never go negative, so you can have this get really close to the x-axis, but it can't cross the x-axis. Okay, so now that we've got both of these drawn, so one thing I want to point out to you, so neither one of these are crossing this axis here, the x-axis. So when that happens and they do not cross, this is what's known as an asymptote. So this is kind of a line that the graph of the function is approaching, but it never actually crosses. Okay, so what I want to do is now that we've kind of identified that, I want to do this one more time, and I want you to use the same values and graph once again, and we're just going to kind of explore now what happens if I multiply this function now by this number outside here. And actually, one other thing I should probably point out before we do this exercise. So we've alluded to this the last time we talked about exponential functions, but the general shape, whether or not it's going up this way or going down like this, that is all driven by the number here. So remember, when this number here is greater than 1, like this, it will open up like this, and it'll have this increasing kind of motion. When it's less than 1, it'll have more this decreasing type shape. So here, this will have more of that increasing shape. So I want you to do the same thing again. So just go from -2, -1, 0, 1, and 2. Plug those in. Hit play when you're ready to see the solution. And you can use your calculator to actually help you out with this if you need to do that. So you can plug all of this in. If you're having trouble figuring out how to plug in -2, so you will put parentheses around this number here, and then the button that you want to use is this little hat button, and you might want to put parentheses around that exponent just to make that happen. But if you do all of that, then you should be able to plug everything in. So let's see, I'm just going to test it real quick on mine. Yep, so my calculator didn't give me any issues. I've got just one of the basic scientific calculators next to me that I sometimes test things out on. So if I plug all this in, so I get 1.65. So if I do this for the next one, so let's see, I get 2 times 1.1 to the -1st. So I'll just plug that in, and I get 818 actually. So this is going to be 1.82. We'll just round up. Okay, so now when I have 0, so this will be 2 times 1.1 to the 0 power. Anything to the 0 power is 1, so this just becomes 2 times 1, so this will equal 2. Then I've got 2 times 1.1 to the 1st, so this is really just 2 times 1.1, so that's just going to be 2.2, of course. And then finally, I've got 1.1, all of that squared. So let's see, if I square that, that will give me 2.42. Okay, so once again, I want to just plot these. So maybe you want to pause the video and do it yourself and then hit play when you're ready. So you just got to kind of approximate these. So I'm having problems plotting for some reason. There we go. Oh my gosh. This software is really great most of the time, but sometimes it gives me problems. Like now, oh my gosh. Okay. There's the next one. Here's 0, 2. At 1, I'm at 2.2, so I'm up here. Oh my gosh. 2.2. And then I've got 2.42. So it's almost kind of difficult to like differentiate these points. So the shape actually isn't going to change. So it's still going to be kind of opening in a similar way, but now this 2 is just kind of impacted our general shape. And so it doesn't really matter what negative value you put into this. This will continue to get lower and lower. It just won't get negative. So the way that this is going to look, let's see, I'll try to draw it from here. So we've still got a shape kind of going like this, and it's still going to look like this, but now it gets a little more flattened out. Let's see if I can draw that slightly better. Let's see, I'll go like this. And boom, like that. Okay, there. So it's still exponential, but now multiplying it by 2, if you compare it to this shape over here. So this was a lot more pronounced, but now when I multiply by 2, so it still goes the same direction, it's just a lot more elongated because of the 2. Okay, so let's do that one more time with this other one. So again, you're going to do the same thing. So go ahead and plug -2, -1, 0, 1, and 2 in. And then I would plot all the points and then hit play when you're ready. So for this one, so I'm just going to go ahead and plug all of these values just right into my calculator, and then I'm just going to fill in the whole Y column. So remember, you're using this caret button here, and then you're using parentheses for those negative exponents. So I'll just show you what the other column will look like. Okay, so I went ahead and just filled that all in the interest of time, so you can kind of see what the values are, and this should make sense, right? So this is less than 1, this number here is less than 1, so these values are now going down, so that makes sense. Now I'm going to do everything, I guess, by 2's in this case, so I'll make all the Y values. This will be 2, 4, 2, 4, so all the tick marks will be a value of 2, just to make this easier to graph. So let's see, 2, 4, 6, 8, 10, 12. There's my first point. Then I've got -1, 2, 4, 6 right here. Then I have 0, 3, so I'll go to this point. 1 and 1.5. So somewhere around there. Oops, and of course. And then finally 2 and 0.75, so it'll look something like this. And so once again, I don't want to cross that axis, that x-axis, but I'm going to have a very similar shape to what I had before because this is 0.5 here, so it's less than 1. So it's very similar to this idea here, but again, it just gets more stretched because of that 3 that goes in front of it. Okay, so now I just have one more thing I want to talk about with exponential functions, so the domain and range. So the thing I want you to notice, the domain actually of all of these is the same. So maybe you want to pause the video for a second and just think about it. So for all functions, so notice just the domain as I move to the left and to the right. So once again, this is that idea of like, you don't want to add anything to this, so right, like this is going off to this diagonal. So I see no reason why it's not just going to keep going this way for forever. So the domain for all of these is going to be negative infinity to positive infinity, but the range is going to be the harder part. So we'll do A, B, C, and D. Okay, so the range, so now we're talking about y values. So we know that these lines have this asymptote, so they won't cross. So now we just have to try to figure out what is that asymptote. So as I go from the bottom to the top, so it looks like here this x-axis is the asymptote. But here's the thing about the asymptote. So this would be the y value here. It looks like it's getting really close to 0, but it's never going to touch. So because it doesn't touch 0, the notation that you want to use a round bracket. We don't have a hard start at 0, right? We get really, really close to 0, but we never actually touch it. So the round bracket in interval notation is what's going to notate that, or denote that. So this starts somewhere around 0, and then it will just continue up for forever. Okay, so moving down to B here. So this is actually the same thing too, right? So even though this goes in an opposite direction, the range, if I just start from bottom going up to the top, this looks like, once again, it's getting really close to the x-axis, and then it's just going up for forever. So that would be my range in this case. Okay, so now let's look at C. So C is a little bit different, and you might have to squint a little bit just to see what the graph actually says. But it looks like here, this y equals 4, this is actually a really clear line where this asymptote is. So the asymptote changed from these two, which had an asymptote of 0, to now the asymptote's at 4. So it looks like this graph gets really, really close to 4, but I can't see it touching 4. And using what I know about exponential functions then, so I'll say that this really starts somewhere around 4 and goes up to infinity for forever. So again, from bottom to top. So we have just one more here then with D. So it looks like in this case the asymptote is here at looks like -2. And so this will start at -2 and then continue on for forever. So again, going from bottom to top. Okay, so that actually is it. That sums up all of M0465. So congratulations, you made it. And best of luck on your finals or your tests or your projects or everything else with it. I hope these videos have been helpful to you.